Okay, I wanted to do a follow-up on the solid state relay switching for the the recycling of energy. Now, I was talking about my block diagram using a solid state relay switching, 2 channels. Only one solid state relay bank, so there's 8 channels in there, there's 8 channels in this one. Only one of these is active at a time. Obviously, if you had both active at the same time, you would have a direct short and things would not be good. Anyway, so what I would have to do is configure, say, channel 1, which is SSR 1, to configure one set of batteries. So this is a logic diagram, really. It's a block diagram. So it would configure one set of batteries in series. So that would require, I believe, it depends on how many cells you're using, but so if you're connecting between ground, I think we used a common ground, so both the batteries on both sides would have a common ground. So the negative and the negative would always be connected together, so we don't have to worry about that channel. But in theory, depending on how many cells we're using, we have to switch in. These cells would be switched to series, and the same block would switch the other cells in parallel. Then when this is disengaged, this solid state relay circuit was disengaged, only then would the other solid state relay be engaged, which would configure this block, these batteries to be in parallel, and these batteries to be in series by switching them around. So anyway, I did a little bit of basic wiring yesterday about how many channels I would need, and I came to a conclusion that if I was using 3 cells to wire them in parallel, I would need 1, 2, 3, 4 channels. So I would need 4 channels for 3 cells. So that would be pretty damn close to using up all the 8 channels, because remember, these are the ones which are wired in parallel. We'd also have to wire some cells in series as well. So obviously, wiring the ones in series, we would need, let's see, actually these numbers are wrong because that's always going to be common. So this particular channel 1 is always going to be connected to ground, so we could ignore that. So I would basically need 1, 2, 3 channels for the series side. So instead of 4 channels, which I initially thought, I only need 3. Just to go over that quickly, the original circuit diagram for the battery comes from whatever did this, his channel, and this circuit is a Tesla circuit. It's Nikola Teslar, and what if I did this? Thank you to him for publishing that on his channel. But this is a circuit that we use to connect the batteries in series and parallel. So as you can see, the batteries at the bottom, the 3 at the bottom are all wired in parallel. All 3 batteries at the top are all in series, and we have a common ground. So these are always connected together. So basically the batteries are back to back. So the negative to the negative, and so that these are charged, these 3 batteries are charged while there is a load across an LED, which is what he did. So yeah, I wanted to just share that so you could get a bit of insight into what the plan of action is really. But I want to use the solid state relay circuits to switch all of that, so instead of manually having to swap batteries around. And I'll probably share that solid state relay circuit with him as well, for him publishing that. So anyway, I just want to give you a heads up on what I'm looking at. So I haven't given up on the other RF stuff, but I'll come back to that later because it's not healthy really. Apparently because of the RF and high amount of radiated energy from this, it's not exactly very healthy because it really needs to be screened. So I'm just going to leave that aside for now. I'm just going to continue working on my other stuff because I don't want to kill myself with this high voltage RF stuff. So I'm just going to focus on the basic stuff for now. So thanks for watching. I hope that gives you a little bit of insight